Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 2 until 3 in the afternoon, and we are in our 8th week of our 9-week course. So as always, to remind you what work you should be submitting for marking, the support questions, the ones with the pencil icons, are the ones to do for practice. These are not to submit for marking. You can decide which ones and how many to do depending on your needs. If you are understanding a concept, feel free to skip questions. You don't have to do them all just because they are there. If you need more help, let me know and I'm happy to send you more practice problems. The answers are in the back of your booklet, so you can check your work to make sure that you are on the right track. And if you're struggling with anything, then let me know so that I can support you. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these questions showing all of your work, your steps in your thinking. This way you can really show me what it is that you understand, and I can figure out what you might be struggling with and how to help you. So how do you actually submit your work for marking? Well, there are 3 methods. The first is to scan your work and send electronically. If you have a device, you can scan your completed work through it. If you have an Apple device, you can use the Notes app. And if you have an Android device, you can use the Google Drive app. These are both free apps that are generally come with the devices and are fairly straightforward to scan. If you'd like to figure out how to actually scan with them, you don't know, I have a tech tutorial videos on my YouTube channel that you can check out, and they walk you through each of these apps and how to scan. If you could only send me pictures instead, if that's easiest for you, no worries. Scanning them just generally makes it one file and a little bit easier to send. But if that doesn't work for you, no worries. Then send them to me through email at studentwork@nnec.owen.ca and cc2bronwyn.slate@nnec.owen.ca. Or you can also send them to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So you can just put it in there at any time and I'll get back to you as soon as I can. Third, you can hand it into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. I have just found out that sometimes things that are faxed can go missing. So if you do send a fax, either give me a call and leave a message or talk to me, or send me an email or send me a Facebook message saying that you have sent work so I can look out for it. Then you can also connect with me through social media. Both my Facebook and my YouTube channel are under the name B. Slate Wahsa. All of our radio Zoom classes are uploaded to YouTube and then shared on Facebook. So you can access all of the videos there and watch replays if you need to. Also, I have short videos that explain common errors and confusing concepts that are up on my YouTube channel. So that is a really good place to go and check out if you're struggling with things. Math is a really visual subject, so I strongly encourage you to access the videos. Just listening to me talk is only going to give you a small portion of understanding. So really, to set yourself up for success, watching the videos is the way to go. If you can't join me live through Zoom or watch the YouTube videos, let me know and I'm happy to send you a copy of the videos so that you get the full experience and really set yourself up for success. If you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.owen.ca. My Facebook is B. Slate Wahsa. you can give me a call at the office at 807-737-1488 or extension with extension 2209. You can also call us toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m., though I teach the last hour of my day, so that is not a great time to try to get a hold of me. All right, we are in our last week of new material. So we are going to finish all of the course material this week, and then next week we will be reviewing. We are looking at lesson 18 today, which is data distributions. Our learning goals for today are that at the end of this week, lesson, you will be able to create a histogram and you will understand how to identify common distributions of data. So you know you've met this learning goal because 1, you can create a histogram using intervals and frequency tables, and 2, you can explain the differences between normal, bimodal, skewed left, and skewed right distributions. Always to answer the question, when will I use this in real life? Well, we are looking for patterns in math helps us better understand the world around us. Sorry, I fumbled over that. Anyway, being able to see patterns is really, really helpful. There are patterns that show up in our lives at all sorts of places, and so understanding that is a really beneficial skill. All right, but as always, let's activate our brain first with some mental math. I don't believe in mad math minutes. They don't set students up for success. They cause stress and anxiety and don't actually teach any skills. As a kid, I was really great at mad math minutes, but then I would be really stressed out about dealing with money or being someplace and having to do mental math really quickly because I didn't have any skills. I just had memorization. So that didn't really help me. So instead, I think it's important to work on strategies that develop comfort and confidence when using numbers so that you are able to do whatever you need to do with terms of mental math. All right, we're going to be doing the question 525 divided by 35 today, using the strategy of partial quotients. Now this, I do write everything out in order to show how the strategy works, but you can think of these just mentally as well and use the same strategy without writing it down if that is easier or more useful for you. So partial quotients is we're just thinking about things in groups opposed to doing long division where we just follow an algorithm, follow steps. Here we're going to think about friendly numbers of groups. So we're trying to divide 35 into 525. So I can see right off the top that 10 groups of 35 fits into 525, and that takes care of 350 of my things that I'm trying to divide. So now 525 take away 350. Well, if I think about this, if I take away 25, if I take away 50 from that, that gets me down to 500, and then that gets me down to 475, and then take away 300, that gets me down to 175. So 175, I can tell that 35 is not going to fit into that. 10 groups is not going to fit into 175. I kind of feel like maybe 5 groups will, but I'm not certain. So I'm going to say 2 groups, because 2 groups of 35 is 70. So then if I take 70 away from 175, I am left with 105. And then I'm going to take away another 2 groups because that is bigger than 70 again. And 105 take away 70. Well, 100 take away 70 is 30. So take away another. So 105 take away 70 is going to be 35 because I have an extra 5. So then I can see that I have 1 group left. and that ends up with nothing remaining. So then how many groups did I get in total? Well, 10 plus 2 plus 2 plus 1 is 15. So 525 divided by 35 is equal to 15. And there we go. All right, mine's on. What prior learning do we need to know to set us up for success today? So we're doing data distributions. So we want to talk a little bit about what data means. So what does data do? In what ways does it matter most? So one, data identifies the relationship between two variables, usually. So we're making connections between two different things that are happening. Two, it allows for the prediction of future or for forecasting based on previous trends of data. So we can get information and make educated guesses about what's going to happen. Three, patterns can be determined in data sets. So we can look at patterns and see and get information about that so that we can be informed about what's going on based on what has happened historically. And four, it can detect fraud and anomalies. I can't say that word, it seems. Anyway, so it can, if things really don't make sense based on the patterns and the data that we have, and this can highlight why something might be questionable or incorrect or trying to fool us or trick us. So having information so that we know what has happened in the past and what is most realistic helps us catch errors and things that might be trying to confuse us intentionally. So then also, I just want to remind you what a frequency table was and how frequency tables work. So frequency, that term refers to the number of times an event or a value occurs. So how often something happens. We use tally marks in a frequency table to collect that information. So instead of writing on Monday, if you're the number of customers, look at this example. So instead of writing down the first one comes in and then another one comes in and writing one again and then writing, oh, 5 come in together and then writing 5, then keep going, having to count how many happened in that day. Doing a tally chart means that you just write one tally for every person. And then when you get to 4, the next person comes across is 5. And you draw a hash line across a diagonal line across the 4. And so now just looking at this, we can see that each of these groupings is equal to 5. And so that we can say, okay, here's 4 groups of 5, so that's 20. Here's 1 less than 3 groups of 5. Well, 3 groups of 5 would be 15, so 1 less would be 14. So it's just a really visual way of gathering information as you have, if you're collecting a tally, if you're collecting a running information, that you don't have all the information as you go, so that you don't have to add up everything at the end, and this information can be changing as you go. A useful tool. Right. Okay, so active learning, what are our new concepts that we need? So always looking again at math around us, so where this information is. So we are looking at histograms today in terms of looking at these data distributions, looking at data. And so here are 4 examples of where the data can show up. And we're going to look at all of these 4 different examples. So these are all histograms. We're going to talk about what histograms are, but these are different ways that these show up in real life. So the distribution of NFL player retirement age shows that most people retire from the NFL around age 33. That is the average, and then it gets less and less as we get younger and less as we get older. Then, so that's one example. Another, looking at test scores and seeing that we're comparing, we have 2 sort of where we have peaks of people who didn't study and how well they did versus the people who did study and how they did, the number of them. So that sort of gives us information. We can compare yearly income and the relative frequency. So how they're most likely people would think that the majority of people make kind of a middle amount compared to the highest amount to the lowest amount. But with this graph, you can see that actually most people make on the lower end of the yearly income in thousands of dollars. And there are very, very few people who make a lot of money. Most people live in poverty or make low amounts of money. And then also another one looking at this graph is deaths in Australia in the year 2012. So a while ago, but it proves my point. So we're comparing the age bracket and the number of people deceased. So how many people? So from folks who do not live in Australia, we kind of think of Australia as this like big dangerous place with all these animals that are going to bite you and eat you or whatever. So you'd think that it doesn't matter how old you are. And here you can see that really most folks die in their 80s. So elderly, just as they do in other places. So even though we think of Australia as a dangerous place in terms of like natural predators and such, that's not really affecting lifespan. So really these graphs show up in all sorts of different places that are really quite diverse, and so understanding them is really important. All right, so distribution of data, this is what we're talking about. Typically, this takes into account the range and the spread of the data, which we talked about, and is usually represented by histograms and dot plots, which we're going to look at too. So a histogram, we're going to look at first, and this is on page 14 of your IL booklet. So it's a graph using bars to represent frequency distribution, so how often something happens. The bar height shows the frequency, and there's no spaces between the bars. That is key why it's not just a bar graph. So here, looking at this diagram, we can see here is our, histogram. And we have a table, so the number of visits to the library, the score, so the number of times, so did it happen once, twice, 3 times, 4 times, 5 times, 6 times, and the number of students, frequency, so 4 students go once, 5 students go twice, 8 students 3 times, 9 students 4 times, 3 students 5 times, 1 student 6 times. And then graphing that, you can see shows that how tall the bar is how often that time happened. So if you're creating a histogram, there's a numerous steps. So we're gonna go through the steps. The first step is to organize your data into a frequency table. And how histograms work is that you need an interval or a range. So here we're looking at finishing times in a marathon. So we're going to look at our time intervals. We're setting our time intervals, and we're saying, okay, we're going to look at people who finish between 1 hour and 30 minutes and 1 hour and 59 minutes. And then our next interval is 2 hours to 2 hours and 29 minutes. And then our next interval is 2 hours and 30 minutes to 2 hours and 59 minutes. Then 3 hours to 3 hours and 29 minutes to 3.5 hours to 3:59, 4 hours to 4:29, 4 hours and 30 minutes and over is how long it takes. So we have these groups. Instead of doing each of these ones individually, we're going to put them in groups to see how often it happens. So then we tally. So we look and we say, okay, we look through and we find all of these ones are ones that are happening between 1 hour and 30 minutes and 1 hour and 59 minutes. And so I write a tally for every time that that happens, and then I cross it off on my chart. Then I look for the next ones and I see I only have 2 hours and 1 minute and 2 hours and 13 minutes. So those all happen, and so I only have 2 tallies in my chart for that interval. Then my next time one, I also only have 2. And as you can see, as you cross them off, it means that you are only looking at less. Then 3 hours to 3 hours and 29 minutes. I also have 2, 3 hours 0 minutes and 3 hours and 10 minutes. Then 3 hours and 30 minutes to 3 hours and 59 minutes. And we don't actually have any, so we have none. Then 4 hours to 4 hours and 29 minutes, we have 1. And then 4.5 hours and over, we have 3. And then our frequency, we just add those up. So we have our tally weight 8, then 2, 2, 2, 0, 1, 3. So we know how often these things are happening. So then our next step on making histogram is to choose our axes. So this is going to telling us relating the information. So generally we have, for the histogram, we have an X and a Y axis. And our time intervals, so is our independent variable, the thing that we got to define. So that's our X axis. And so then we put on our references. So here I put it to, for simplicity, I put 0.5, 1, 1.52, 2.53, 3.54, 4.55, so that we can see, instead of putting minutes on, I've just had to put half hours. And remember, we're going from in between, right? So from 1.5 to 159 is between 1.5 and 2. So that's where that bar is going to go. And then on our y-axis is our frequency. And here we just spread out an even number and labeling it up, make sure that we're above our highest amount. Our highest amount was 8, so we're going all the way up to 9 to give myself a little bit of room. Then step 3, we plot the frequencies in touching bars. So our first one was 8, and that is from 1.5 to 2. Then we have 2 from 2 to 2.5, 2 from 2.5 to 3, 2 for 3 to 3.5, then nothing from 3.5 to 4, then 1 from 4 to 4.5, and then 3 from 4.5 to 5. So this shows us how most people in the marathon, or it's quite common for marathon runners to finish between 1.5 hours and 2 hours. And then beyond there, people were more inconsistent about where people are, how long it takes people to run. Okay, so that's creating a histogram. So the real trick is creating your intervals and making sure you have your intervals. I didn't mention this, but your intervals are equal. They have to be the same. Your scale has to be consistent. That's super, super important on both your axes. So now you can do the support question on page 15, question number 1. All right, so now we're going to look at common distributions. Now that we know how to create a histogram, we need to figure out how to understand it and figure out what information it is telling us. So this is on page 16 of your IL booklet. And first, we're going to look at normal distributions. So this is a true symmetric distribution of data values. The mode, median, and mean are all the same and together at the center. So here in our diagram, you can see our histogram. All of our information is symmetrical. And it's like there's a mirror on the middle that's 50. And that's where your mean, median, and mode all are. It's called unimodal because it has one mode. They don't have more than one mode. It's only has one hump. And it's also known as the bell curve, which is it's sort of common usage and how when people talk about the bell curve, this is what they're talking about. That most things happen right in the middle, and that as we move towards both our lowest values and our highest values, we lose at sort of a similar rate in both directions. All right, so now we're looking at bimodal distribution. So this is when your data has the appearance of 2 peaks. So you have 2 high points when you're looking at your data. So the frequencies are clustered around 2 modes. It can be symmetric or not. You might have one. So with two modes, you would think that they're going to be the same. They might be, or they also might be similar, like significantly different than the rest of your information. And so it's obvious that you have two modes, even though they are not, you have two peaks, even if you don't have two equal modes. And so it's a data set that has two modes or 2 points that all the data sort of cluster around. Okay, now we're going to look at skewed left distribution. So it's like a normal distribution, but has been pushed away from the left. This is where I always get backwards. To me, I want skewed left to means that the information is gathered, collected on the left, but is the opposite. You're pushing your information away from the left. So you're skewing, your lower values are at the left, and your information is pushed away from the left, is how I have to think about it to make it make sense or to remember. So it has sort of a tail on the left side of the distribution. It has the lower values are on the left side of the distribution. It's also known as negatively skewed. So your values are skewed because you are negatively skewed because it's your like you have a negative. It's not a negative. I don't know why it's called negatively skewed. I can't remember. Sorry. Your mean is less than your median, which is less than your mode. So that's how one way you can look at your exact values. If you're calculating them, that can tell you if you're left skewed or if you have a negative skewed. You're skewed to know that it stores the negative? No, it doesn't. These ones I struggle with because I feel like they're contradicting themselves. Anyway, figure out what makes the most sense for you to how you can remember it. So now we talked about a left skewed. Now we're going to talk about right skewed distribution, which is the opposite. So it's again like a normal distribution, but has been pushed away from the right. It has a tail on the right side of the distribution. And it's known as positively skewed. The mean is greater than the median, which is greater than the mode. And then finally, we have a normal distribution. Or not normal, uniform distribution. This indicates that the data is very consistent. Sorry, looking at the graph, you can see that though the data is not all exactly the same, it is very consistent. So it is happening at roughly around, everything's happening at about the same frequency. So it's fairly straightforward. Okay, and now you can do the support questions on page 17, which are 2 and 3. And that is all of our information. So let's look at some practice questions to actually apply what we've learned today. All right. Identify each type of distribution for number 1. So again, this is one of those situations where we're looking at graphs. So really seeing the visuals is going to make the most sense. We're analyzing visuals. So just listening really isn't going to help you understand because you have to be able to look and interpret the information on your own. Anyway, so I will describe to the best of my ability. These are not actually histograms. I captured them from somewhere on the internet to just show the types of distribution, but as you can see, our bars are not touching. They are equidistant away, but that they're kind of weird looking. And sorry, I should fix that. I was probably supposed to fix that before, just the way my life goes. Okay, so number 1, we're looking at adult weight. So the frequency versus the weight in kilograms. So you can see, doesn't matter. We're not looking at the data specifically. We are looking at just sort of the positioning of the bars. So you can see here, we have kind of our highest information is roughly in the middle. And then as we go down to both directions, we see that we are going down at a similar rate to in both directions. And so that is a normal distribution. The second one where we have school days and we're looking at months and the number of days per month. And here we can see that throughout all of the school months, it doesn't have the summer months, but through all of the school months, we have roughly very similar number of days per month. So this is a uniform distribution. Then we have class marks. And so here we are looking at the percentages and the frequency. And we can see that for the class marks for this, whatever class this is representing, it's not our class, it's just made up information. Most of our students are clustered around this 60 to 70%, which is on the right. So it's skewed away from the left, and we are going down from there. So this would be skewed left because the information is pushed away from the left, is how we remember it. And then lastly, looking at this one, which is casino earnings, we can see that most of the casino winnings happen at low values. And though some do happen at higher values, most happen at low values, which we can see are clustered here at the left and pushed away from the right. So more people are winning lower amounts of money opposed to higher amounts of money. So this is skewed right because the information is pushed away from the right. Okay, number 2. The pulse of 30 people were taken for 1 minute and recorded. These are the results: 66, 79, 53, 81, 84, 76, 76, 67, 64, 83, 92, 56, 65, 77, 91, 61, 71, 86, 73, 87, 71, 67, 71, 81, 86, 62, 77, 91, 72, 68. Sorry, 30 numbers to read. Okay, so why is it hard to spot the trends in the data as it appears? So the same way that it was challenging for me to read them all, there is just a lot of data. And so that makes it really hard to see what patterns, see what trends are happening, and be able to make any predictions or make any information. So part B now says, let's construct an histogram. So remember with histogram, first we're going to tally our information. So we're going to see, I'm going to look and I'm going to see, well, my lowest, so I have a 53. I'm 56, so 53 is lower. So I think 53 is my lowest. So instead of saying 53, I'm going to say 50 to 59, and then 60 to 69, 70 to 79, and 80 to 89, 90 to 99. Nothing is above 99. And now we can tally. So what we could do is we could go through and find all the ones for that fall into 50, 59. What I would prefer to do is start from the beginning and then just tally them, put them in the right places. So 66, 61 goes, so we just go through and we tally each of them. I'm not going to read the numbers out as I go, as that will be tedious. I already did that. So as you can see, just every number I cross off and then I put in the right interval. And I'm using tally systems so that it'll be easier to count once I'm finished. Oops. And you just, as you can see, it's not too tricky to do. And it helps organize our information really quickly. Fairly quickly, I guess. And makes it much more manageable. Setter frequency we can see is for 50 to 59 is 2, for 60 to 69 is 8, for 70 to 79 is 10, for 80 to 89 is 7, and for 90 to 99 is 3. And then now we can draw our x-axis and our y-axis. So we're comparing pulse to frequency. I am just doing a sketch. If you are doing this to hand it in, you should use a ruler or graph paper to really make sure your intervals are consistent. As you can see, my intervals are not exactly the same. They're close, but not exactly. And so you want them to be the same. Now, when you're doing your axes, I always am a stickler for you got to start at 0 and be at the same frequency as you go up. Not frequency, consistent intervals. But sometimes that just doesn't make sense. So for frequency, it makes sense to start from 0 and go up to 10 to 11. But from pulse, it doesn't make sense to go from 0 because realistically, you're not going to have a pulse of 0. So it just doesn't make sense to start that far. You're going to have a whole bunch of space that is not useful. So you want to make it make sense. So then you draw your bars. Again, if I was doing this properly, I would be using a ruler opposed to my wiggly lines, but this is the joys of doing it on the computer, going on the fly. But you can get the idea. So there we can see that we sort of have a normal distribution. All right, number 2, use your graph, part C, use your graph to answer the questions. In which interval does the most common pulse occur? So we look back and we can see the most common pulse happens between 70 and 79. That is our interval. In which interval does the least common pulse interval occur? So our lowest one was at 50 to 59. We are not including ones where we didn't have any information because that isn't helpful. Number 3, scores are shown out of 100 on a college entrance exam. What type of distribution fits this data? So here we're just looking at our tallies. We're going to tally up our data. So we have 10. 15 plus 2 is 17. 10, 20, 6. 10, 20, 35. 10, 20, 30, 43. 10, 20, 31. 10, 1 less than 20 is 19. Okay, so we went on the distribution. So again, we're going to do a quick sketch of a histogram. We didn't have to organize the information this time. It was already organized for us, but we can make a histogram. So we're going from 30 to 40, 50, 60, 70, 80, 90, 100. And then I'm going to go up by fives, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So you want to make sure that you're going up at a consistent amount. And even though my numbers don't match, this tells us roughly where they're going to show up on that, in that range. So from 30 to 40, it's a frequency of 10. From 40 to 50, it's a frequency of 17. So that's between 15 and 20. From 50 to 60 is 26, so just above 25. From 60 to 70, 35. From 70 to 80, 43. From 80 to 90, 31. And from 90 to 100, we have 19. So this, I would say, is a skewed left because our information is pushed to the right and away from the left. So because especially if you think about the fact that you have 20 and 10 down here, where there's nothing, so most information is on the higher end. Number 4, the measures of central tendency are given for 3 data sets. Identify a likely distribution for the data. Explain. So here we have mean equals 7, mode equals 10, median equals 9. So our mean is less than our median, which is less than our mode. And so to sketch that, again, just a sketch, this does not need to be perfect. Mode means that that's our highest amount, right? So from our mode, then our median is our middle value and our mean is the average amount. So that means that we are skewed left because we are pushing everything to the right. Mean equals median, mean equals 21, mode equals 21, median equals 21. So they all equal the same. So if it's all equal the same, then it's a normal distribution. And mean equals 5, mode equals 1, median equals 2. So mean is greater than our median, which is greater than our mode. So our mode is the highest, is the most frequency, is the lower values. So the mode is what happens most often, which is at a low value. And then everything else increases, or sorry, decreases from there. So it's skewed right. All right, let's consolidate what we've learned today, as that's all our practice questions today. So for lesson 18, we've been looking at data distributions. So we looked at histograms and how they are like a bar graph, but with touching bars as the data is continuous. So there's no gaps unless that information is missing, like unless there's 0 frequency for that information. It shows data frequency in intervals is what a histogram does. A normal distribution is a symmetrical around the mean. Remember, where mean, median, mode are equal. Bimodal distribution has 2 peaks or 2 modes, so 2 areas that the information is clustered around. Left skewed distribution is the tails on the left side, the peak is on the right. So the mean is less than the median, which is less than the mode. A right skewed distribution is the tails on the right side, the peak is on the left, and its mean is greater than the median, which is greater than the mode. So hopefully you're feeling confident with our success criteria, that you can create a histogram using intervals and frequency tables. And 2, you can explain the differences between normal, bimodal, skewed left, and skewed right distributions. All right, if you have any questions or concerns, as always, please reach out and connect with me. This is why I am here. I want to support you however I can. So you can call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. You can email me at bronwyn.slate@nnec.on.ca or connect with me through Facebook, where my name is B. Wahsa. Remember, all of our videos are up on YouTube under the channel, or on the channel that is also called B. Wahsa, and all of ours are found under a playlist called MBF3C. So that is the great place to go and find all of our lessons where you can replay them as you need. Thank you so much for joining me. I hope you have a lovely day. Good luck with your work. Miigwech.